Hey there, Python pioneers, and welcome to another video. In this video, we're going to take a look at lists in Python. So what I want you to do is imagine a list as a row of numbered lockers in a gym, each capable of holding an item. These items could be anything. For Python, we're going to say that they could be numbers, words, or even other lists or lockers. The beauty of the Python list is its flexibility. The boxes or items don't all have to be the same type. In some programming languages, a list of items, they all have to be the same type. In Python, that's not the case. You could have a number in one box, and in the next box, you could have a word, or you could have another list in the next box. So, very cool, very helpful. And so, let's try to take a look at why would you need that. Let's say we have a program, and in this program, we want to ask the user how many expenses they've had. We're trying to help them keep track of how many things they've bought, maybe, right? And in this app, we keep getting feedback from the user, and we ask them for an expense, right? And then we also, maybe we want the description of this expense. Well, how do we store that information? Based on what we've learned so far, you might be tempted to do something like expense one, and then whenever you get that feedback from the user, you're like, you set it here with a function call. Maybe you have some function called get expense. We'll just say maybe we have a function called get expense amount or something like that, right? And then we have another expense description we need to get, right? So we have this expense and this expense description that we're getting from the user. And then maybe we have some function, called get expense description or something, right? Now, if we wanted to keep track and maybe get 10 expenses, we might just copy this code, 10 times, right? And let me zoom in a little bit, get rid of that for you. So we might copy this code 10 times and, just change the number on the end of the variable, right? And you could do that, but it's really hard to maintain and it just takes up way too much space, right? What we really want here is a variable that we can just store these amounts in sequentially, like a list, right? So let's look at, instead of like defining every variable that you need in your code like that, let's define a variable that can hold other variables or values. And it can hold many of them in a list. So in order to do that, let's just create a variable called myList. We're going to put the equal sign, and to define a list, we're going to use the square brackets. So the square brackets tell Python that, hey, the information in here is a list because the square brackets are right next to an equal sign. You might see square brackets in other places, and as a matter of fact, you're about to see them when we access the members of this list. But when Python sees the square brackets after an equal sign, it knows the data inside of these square brackets is supposed to be a list. You could actually just stop right there, and now you have defined a empty list. If I try to print my list, we're just, I don't know why I got that A in there. And if I run that, it just literally prints the empty list. But there's not an error or anything. But let's say we want to actually add items into our list. Now, we talked about it, And a list can have all different types of data. It could be strings or words. It could be floating points, integers, other lists. And when you have a list inside of a list, that's called a nested list. Just so you know. We're not really going to dive too much into that. But when you need a multi-dimensional list, so for example, like an Excel spreadsheet is multi-dimensional because you have a bunch of rows, but you also have a bunch of columns, right? Think of a list as one row, right? And you have all these columns, but you only have one row. Well, what if whatever data you're representing needs to have rows and columns, which we will get to when we start looking at automating Excel spreadsheets and things like that. You need multi-dimensions, right? You need rows and columns. So for now, we're just imagine basically a list is a row of data. So we'll just use, for example, cat. And then we'll have the next item or element in the list is 10. And then we'll have another one. And we'll call this one pencil. And then we'll have a floating point number. Okay? So we have 4 items in our list. So now if we print my list, it prints those items. Very well. What if I only want to print one of the items? What if I specifically want to print the first item? The first item, and we've talked about this before, when we count in programming, we always start at 0. So the first item is going to be located at the 0 index, is what we call it. So the index is the place in the list that the item is found. So we start counting at 0. The next item or index is 1. The next one is 2, all the way to the very end. And the book actually has a great example of this. So if you haven't already, I recommend going and reading Automate the Boring Stuff, chapter 4, where we learn about lists. That's what we're going off of here for the next few videos. We're basically doing a video format of some of that material and coding together and learning together. But in chapter 4 of Automate the Boring Stuff, they have this graph, and I think it's pretty useful to show what I'm talking about. So let's say you have a variable called spam, and it's a list with 4 strings in it: cat, bat, rat, and elephant, right? Each element is separated by a comma. And just like my list, every element is separated by a comma. I use single quotes for my strings. It doesn't matter, right? Single quotes or double quotes. But the important part is you separate each element or item with a comma. And then when you're counting, spam 0 is the first element and it points to cat. Now notice how they are accessing the elements. So it turns out if you want to access a specific element at a specific index, you type in the variable name for the list, you type in square brackets after it, and then you type in the index of the item you want to access. So if I want to print cat is the first element, the first item in the list, so it starts at 0, right? I can print my list at 0. That's how you could read that. And if we run that, it just prints cat. Now here is a nice thing about this. You can change these, right? So this is a way to store variables, but you can also change variables that are stored in the list. So I can say my list at 0 equals dog. And now if I run this code, it prints dog when I print the element at 0. So these are not unchangeable. You can change them. And we have a special word for that. It's called mutable. So if a data type is mutable, it's changeable. And actually, lists are mutable. That means that we can delete elements from them. We can add elements to them. The opposite of that is a immutable object or immutable variable, and you can't change those. So you have to take the variable and assign it to a new variable to change it. But for now, we'll look at that a little bit more later. But for now, just know that a list is a mutable variable that you can change. Okay, so let me see. Let me pull up my notes. Okay, mutable, nestable. So just so I could show you what that looks like. Also, you can just put another set of square brackets in here and start defining another list. So I have a list of 1, 2, 3, 4 inside of this list. And if I print my list, I mean, it's just going to print the whole thing. But if I print my list at this index, which should be the third index, right? I tried to give you a second to think about it. Okay, it prints out that array. Now, what if I want to access, the second element in that array? Well, you just type another set of square brackets and type in the index of the element you want to access. So if I type in 1, that's going to be the second element, so it should be 2 there. If I print that, it prints 2. Now let me explain why this works. Think of my list at 3 as saying it's going to go and get this list, right? And so all of this code right here changes to, points to the nested list, right? That's hard to read, but just to demonstrate, it no longer is just saying my list at 3. It actually goes and gets that list, and then now we're trying to index into that list, and we already know how to do that. All you have to do is type square brackets, right? And the index you want to get to. So when you have a nested list, you just use square brackets again. And we'll talk more about that. If it doesn't immediately make sense, that's okay. But that is going to be useful when we start talking about working with Excel or Google Sheets. Okay. All right. So at this point, we're ready to dive into some of the features that lists have. But before we do, let's briefly recap on what we talked about in our previous videos. So functions, right? They start with def. You type out some name for the function. Maybe you give it some parameters, and then you throw on a colon, you put some code in here, and then you maybe return a value, right? That's a function. And we're actually using those all the time, right? We're using print, len, float, string, int, there's all kinds of functions we're using. But there's a new type of function that I want to tell you about. And it's called a method, right? So a method is the same thing as a function, except it's called on a value, right? So instead of just typing out the function name and then putting in a value, you actually are going to use a method on a value. So let me show you what that looks like. It's a little different, but it's basically the same idea as a function, but that function is only available to certain values. So let's see what that looks like. So for example, on a string. Let's talk about one that you're used to. And by the way, strings have a lot of these methods, and we're going to get way more in detail on that in the coming videos. So we've learned about string, like, my name equals Jason. And strings have a method called lower. So if I print my name, without doing anything, let's keep that list to work with it in a minute. Comment it out. So if I print my name, do nothing, it's going to print with a capital J, right? But what if I don't want to do that? Now, there's some times where maybe you don't want to do that, right? Maybe you're checking in an if statement and you just want to check, like if you're checking, for example, the word, you're in a while loop and you're waiting for a user to tell you they're done. And you ask them to type in done when they're done. Maybe you don't want to check for what if they type capital D done. I'm checking for lowercase d done. Those are different strings, right? So I can't say, if capital D done, is that equal to lowercase d done? It's not. So all the variations of capitalization they could use is really annoying, and you don't really want to test for that. So a method you can use on a string is lower. And if I print that, it prints all lowercase, which is super nice, right? Because instead, for example, I could say if my name equals Jason, I'll say hello Jason, right? Now if I just do it by default without doing the lowercase here, it doesn't do anything because I've got an uppercase in my name there, and then I'm checking for a lowercase here. So all I have to do is put lower, run that, and it works. This evaluates to true. So that right there is a method on a string. So all it is a function called lower, but to access that function, you have to type a period after the variable name and then the function. Now each certain types of variables have different methods. Not all methods are shared across all variables. So strings have special methods, lists have special methods you can use. And like I said, we'll learn more about strings in the coming videos, but for now, let's look at some methods that lists have. So let's say we have a list right here, and I just have a list over here of my notes to make sure I cover some of the common methods. So first off, let's not mess that up. Okay, so one of the first ones we'll look at is insert. So what if I want to add a value in at the second element or the second item? What I can do is type out my list dot, right, the period, insert. So I'm trying to use that method. In some programming languages, we call those member functions. And then I'm going to insert the value new entry. Just going to literally call it new entry. Then I'm going to print my list. Now if I run that code, oh, so I've totally left off the index. So the index goes first, and then the value you want to insert. And in this case, I want to go in the second place, which we start at 0. So I'm going to insert in the first index. Now if I run that, you'll notice new entry shows up between cat and 10. Pretty cool. Now that's weird, right? So I never assigned my like this function call that happened here. I never assigned it to the variable again, which we've had to do in all other cases. Why didn't I have to do it here? That's because the list is directly changed by calling this function. It's a mutable variable that is passed by reference when the insert function is called. Basically, what that means is certain times when you use a variable, it's passed by value. And when you do that, you're just passing in the value. And, if I pass in the value for an add function, I make my own add function, and it has two parameters, x and y. No matter what I do in this function, if I say x equals 100 and then y equals 200, and I just say return 5, whatever, it doesn't matter. When I call this function and I pass in, let's say I have a variable equals 10, and then I say add my var, just want to show you this, plus 10 or something, right? The main thing is, right, if I pass in my var in this place, technically it's x, right? Me saying x equals 100 here doesn't change x down here, right? Because of scope, and we learned about that, right? So the variables pass in as a value, so the value 10, let me just change this to 15 so it's more obvious what we're talking about. Instead of passing in my var, technically actually just sends over the value 10. Now it's different for lists. Lists don't work that way. Lists, when you pass a list into a function, or you call one of these member functions, the actual list that you defined is changed. So if I have a function called, update list, and then I have a list, my list, and inside of here, I just take my list, like we talked about, and I change the first value, and I set it to updated by update list. Okay. Then if I come down here and I say update list, my list, let me just change this name so it's not confusing either. We'll call this temp list, right? Because that could be how you get confused. You think this is a temp list, and then when I call my list, let me get rid of that one and that one. Okay, so I have this list called my list. I have some function that's supposed to change the first value of the parameter that's passed in. It doesn't return anything. So let's see what happens when we print my list. You would think maybe that nothing changed because we never returned. We're only changing the parameter that was passed, but it changes the list. So that's something you have to pay attention to, because lists are passed by reference. And again, that's different than passed by value. So what you've worked with before was values being passed. Passed by reference means that the actual memory location on your computer is passed to that function. And when it goes and tries to find the value of that variable, it looks in the memory location. So since you gave it the memory location, any changes that it makes actually change the value in the rest of your program. Because when you get back to the rest of your program after the function is over, your program's going to go look at that place in memory where it left that variable, and the variable is going to have changed. So it's just going to roll with it. So just something to keep in mind with lists. Okay, so that is the idea of passing by reference with lists. We looked at insert. So adding an element at some index, if I wanted to insert at the very end of the list, one way I could do that is it's called negative indexing. Kind of cool. -1 is the last element in the list. So, we'll call it new last. And if I run that, that's weird. -1, what did I do wrong? Somehow it's before that element. That's weird. -2. Let's try that. Yeah, it's just like skipping that last array. Weird. Oh, look. If I say my list, that's what it is. Okay. So, a little weird. I kind of combined two things. So, basically, you can use negative indexing. Right. So I can say -1. Print my list at -1, right? That will print the last item. That makes sense. But when you call insert, it's going to insert at the last place, and whatever was in that place shifts to the right. So I'm glad we actually ran into that weird quirk. If you could tell, I don't actually use insert in that way. There's actually another function that's makes much more sense to use for adding something to the end, but we haven't talked about it yet, so I was trying to show you insert. But basically the idea is, right, if I call -1 with insert, it's going to go and find the very last element, which is this element. And for the sake of not getting confused with these other functions, we're going to change that to 45.3 or something, but the actual number. Okay, so it's going to go, it's like, okay, well, this is the -1 index. You want to insert a new element, we're going to call it. Well, I'll insert it here where 45.3 is, but since I'm putting a new value here, I need to shift 45.3 to the right. So that's what happens. You notice 45.3 is shifted to the right. New element is shifted in as the fourth element. 1, 2, 3, 4. Oops. Gotta be careful when you try to highlight in this editor. Okay. So you can do negative. -2 is the second to last. So instead of using insert here, just for the sake of showing negative indexing, -2 is pencil, right? So if I print that, oh, we get pencil. -3 is just counting backwards, basically. 1, 2, 3, 10. And you're probably thinking, wait a minute, why don't we start with 0 and we count backwards? Because there's like no -0, like we just, we like to keep it a little confusing in programming. There's no -0, so when you start from the back, it's -1. So 1, 2, 3. So -3 would be 10, and so it is. Okay, so it's negative indexing. That's insert. Insert, you just provide that index right, and then the element value, it could be a variable here if you want. There's nothing wrong with that. If I had my name as a variable, I could just literally insert the variable. That works just fine. And then when I come back later, if I just say, let's insert this at index 1, then if I come back and say my list, well, first off, let me show you that works. my name is inserted, right? But if I come in and say my list at 1 equals Fred, I can change it, right? No problem. But what happens if I uh, change my list at 1 equals Fred, and then now I try to print my name? What does that do? Oh, so it's my name is still Jason. See, this is one of those things you have to be careful of. Strings are immutable. So lists are mutable, they can be changed. Strings are immutable. So you actually can't change the value of a string, which sounds weird. But what actually happens is you just create an entirely new string and assign it. So I can say that a string, that used to be Jason is now Fred. But when I do that, it basically trashes the old value entirely and just overwrites it with Fred. That's different than a list, right? A list has a place in memory, and I can go in and modify that memory and say, hey, in part of your memory, down here on the third item, delete that thing or add a new thing. That is modifying the list in memory. Can't do that with strings. So when you insert the string into the list, it just copies the value. It's passed by value into the list. Then you can change that string all you want. It just knows there's a string there. If you want to change it to a different string, you can. You just can't go in and do something. Well, we haven't talked about it yet, but the idea is strings are actually sequential data. It's a sequential data type, just like a list, right? A list is a thing of a bunch of items that are numbered. Well, so is a string. It's just a bunch of characters. And actually, just to show you, like my name, we're gonna get more into this, so I don't want to dive too much into it right now, but like my name at 0 would be J. Oh, I didn't finish that line. So if I print the first letter of my name, it's J. So you can access each of the characters individually because it actually is just a list. Now, here's where the string and the list differ, right? With a list, I can say my list, which we did. I just deleted it, but my list at 1 equals Fred, right? And I can change the list. But I cannot do that with a string. If I try to say my name at 0 equals, instead of Jason, maybe I'm going to change the first character to an H. Hasten. And it's like, what are you talking about? You're not allowed to do that. Which, take it out of the print even, just so you, because that actually is not where you should do that. So, object does not support item assignment. I had a different error because I did it inside of print. But when you put it outside of print, you can't do that. So strings are immutable. Okay, so I think this video is getting pretty long. So what we're going to do is break it up, and I'm going to break it up into several other parts. And in the next few parts, we're going to look at functions that you can use with lists, some of the methods that you can use with lists, some of the common operations on lists, and hopefully after all of those, you'll be well-rounded. This is a very useful data type, and you're going to use it all the time, almost a guarantee. So, yeah, just stick with me. I know it's a lot to cover here, but I'm trying to be as thorough as I can. That way, you have a really good understanding of one of the fundamental data types here in Python. I appreciate your time so far, and I look forward to seeing you in the next video.